They built the engines that powered America's highways for decades. The distinctive yellow paint and cat logo meant one thing to truckers: bulletproof reliability that could haul any load, anywhere, anytime. But in 2010, Caterpillar shocked the trucking world by walking away from on-highway engines entirely. Not because they lost, but because they quit. This is the story of how America's most trusted engine manufacturer abandoned the drivers who made them legendary. To understand the magnitude of Caterpillar's exit from trucking, you need to understand just how dominant they were during their golden era. The 3406 series engines weren't just power plants. They were symbols of American industrial might that earned the devotion of truckers who demanded nothing but the best. The 3406B, introduced in the early 1980s, established Caterpillar's reputation for building engines that could handle anything the road could throw at them. This 893 cubic inch inline six produced impressive power for its era while maintaining the mechanical simplicity that made it rebuildable virtually anywhere. The deep skirt block and 7 main bearings created a foundation that could withstand extreme loads without failure. The 3406C refined the design with improved fuel delivery and enhanced durability, but it was the 3406E that became the stuff of legend. Introduced in 1993, the 3406E was Caterpillar's first fully electronically controlled heavy-duty diesel, utilizing an advanced electronic control module, ECM, for precise fuel delivery, diagnostics, and performance management. This model marked Caterpillar's transition from mechanical and semi-electronic designs to full electronic control, while still maintaining the mechanical robustness that operators demanded. What made these engines special wasn't just their power output. Though the 3406E could be configured from 435 up to 600 horsepower, and even higher for industrial variants, with torque ratings from 1,250 to 2,050 pound-foot. It was their fundamental design philosophy that prioritized longevity over everything else. Caterpillar engineers built these engines assuming they would be rebuilt multiple times over their service life, with components designed for easy replacement rather than planned obsolescence. The rebuildability factor was crucial to Caterpillar's success in the owner-operator market. Independent truckers appreciated engines that could accumulate 500 to 800,000 miles before requiring major overhauls, and when that time came, the work could be performed economically. Many 3406 blocks went through multiple rebuilds, accumulating well over 1 million miles of service. Truckers trusted Cat for reasons that went beyond simple reliability. The engines delivered power in a way that made sense for highway hauling, smooth, linear torque that could pull heavy loads up steep grades without strain. The fuel delivery systems were robust enough to handle varying fuel quality, and the cooling systems were sized to handle sustained high-load operation. Cat's street credibility in owner-operator circles during the 80s and 90s was unmatched. Walk through any truck stop, and you'd hear drivers comparing notes about their Cat engines with the kind of reverence usually reserved for family heirlooms. These weren't just engines, they were partners in business ventures where reliability meant the difference between profit and bankruptcy. The yellow paint and Cat logo became symbols of quality that transcended mere brand loyalty. Drivers who ran Cat engines formed an informal brotherhood, sharing maintenance tips and rebuild techniques that kept these engines running long past their intended service life. Independent mechanics loved working on Cat engines because they were designed to be serviced. The fuel injection systems used proven technology that could be understood and repaired with conventional tools. When problems occurred, they were usually straightforward to diagnose and fix, unlike the complex electronic systems that were beginning to appear on other engines. The 3406 series also earned respect for their tolerance of less than perfect maintenance. While proper care was always recommended, these engines could survive neglect that would destroy lesser power plants. This forgiveness was crucial for small operators who might not have access to dealer service networks or the budget for frequent professional maintenance. Fleet operators also appreciated Cat engines for their predictable operating costs and strong resale values. Trucks equipped with 3406 engines commanded premium prices in the used market, and the engine's reputation for longevity made them attractive to buyers who planned to keep trucks in service for extended periods. By the mid-1990s, the trucking industry was beginning to change in ways that would challenge Caterpillar's traditional approach to engine design. Rising fuel costs were making efficiency a higher priority than raw power, and early emissions regulations were signaling that the era of purely mechanical engines was coming to an end. The fuel crisis of the early 2000s hit the trucking industry particularly hard, forcing operators to focus on miles per gallon rather than just horsepower and torque. Engines that had been acceptable when diesel was cheap became liabilities as fuel costs consumed larger portions of operating budgets. The industry began demanding engines that could deliver the same performance with significantly better fuel economy. Emissions regulations were also beginning to tighten, with the EPA implementing increasingly strict standards for nitrogen oxides and particulate matter. The 2002 and 2004 emission standards required significant reductions in pollutants, and manufacturers knew that even stricter requirements were coming in 2007 and 2010. Competitors like Cummins quietly began adapting to these new realities by partnering with emissions technology suppliers and investing heavily in research and development. Cummins worked with companies like Fleetguard and Holset to develop integrated solutions that could meet emissions requirements while maintaining the performance characteristics that customers demanded. The smart manufacturers recognized that the future would require sophisticated after-treatment systems, advanced electronic controls, and close collaboration with suppliers who specialized in emissions technology. They began forming partnerships and joint ventures that would give them access to the expertise needed to compete in the new regulatory environment. Caterpillar, however, chose a different path. The company's leadership was confident that their engineering expertise could solve the emissions problem internally, without relying on outside suppliers or compromising their traditional approach to engine design. This confidence would prove to be both arrogant and costly. Cat doubled down on independence, believing that their decades of experience in heavy-duty engine design gave them advantages that competitors couldn't match. The company's engineers were convinced they could develop emission solutions that would maintain the power, reliability, and fuel economy that customers expected while meeting regulatory requirements. This go-it-alone approach reflected their corporate culture, which had always emphasized self-reliance and internal development over partnerships and collaboration. The company had built its reputation by controlling every aspect of engine design and manufacturing, and leadership was reluctant to depend on outside suppliers for critical technologies. The decision to develop emissions technology internally also reflected Cat's assessment of the competitive landscape. Company executives believed that relying on the same suppliers as competitors would eliminate any technological advantages and force them to compete solely on price and service, areas where Cat's premium positioning might be vulnerable. In 2004, Caterpillar introduced ACERT, Advanced Combustion Emission Reduction Technology, Caterpillar's in-cylinder emissions control system that initially sought to meet regulations primarily through combustion changes, but eventually required additional after-treatment systems like diesel particulate filters as standards became stricter. The technology incorporated twin turbochargers, sophisticated EGR systems, and complicated electronics that promised to reduce emissions while maintaining performance. ACERT was supposed to be Caterpillar's answer to the emissions challenge, a sophisticated system that would demonstrate the company's engineering superiority while avoiding the complexity and cost of selective catalytic reduction systems that competitors were adopting. The technology used multiple fuel injections per combustion cycle and precise timing control to optimize the combustion process. The system featured twin turbochargers in series, with a smaller turbo providing boost at low RPM and a larger unit taking over at higher speeds. This arrangement was designed to improve throttle response and reduce turbo lag while providing the airflow needed for clean combustion. The EGR system recirculated exhaust gases to reduce combustion temperatures and limit nitrogen oxide formation. On paper, ACERT seemed like an elegant solution that would allow Caterpillar to meet emissions requirements without urea injection systems that competitors were implementing, although DPFs were eventually required. The technology promised to maintain the mechanical simplicity that CAT customers valued while delivering the clean operation that regulations demanded. In practice, ACERT became a nightmare for operators and mechanics alike. The complex turbocharger system was prone to failures that were expensive to repair and difficult to diagnose. The twin-turbo arrangement created heat management challenges that stressed cooling systems and caused frequent overheating problems, particularly in heavy-haul applications. The sophisticated electronics that controlled the ACERT system were sensitive to electrical problems and required specialized diagnostic equipment that many independent shops didn't possess. When problems occurred, troubleshooting was complex and time-consuming, leading to extended downtime that cost operators money and damaged CAT's reputation for reliability. Fuel economy, which had been a selling point for previous CAT engines, became a major disappointment with ACERT. Many operators reported that ACERT-equipped engines consumed more fuel than their predecessors while delivering similar or reduced power output. The complex injection strategies and turbocharger systems that were supposed to optimize efficiency often resulted in worse real-world fuel economy. Mechanics hated working on ACERT engines because the systems were difficult to service and prone to recurring problems. The twin-turbo arrangement made access to engine components more difficult, and the complex electronics required specialized training that many technicians didn't have. Independent shops that had built their businesses servicing CAT engines found themselves unable to properly diagnose and repair ACERT problems. Drivers lost faith in Caterpillar as ACERT engines failed to deliver the reliability they expected from the CAT brand. Forums and truck stops buzzed with complaints about overheating, poor fuel economy, and expensive repairs. The engines that were supposed to demonstrate CAT's engineering superiority instead became symbols of the company's disconnect from customer needs. Despite mounting evidence that ACERT was problematic, Caterpillar kept defending the technology and insisting that the problems were due to improper maintenance or operator error. The company's engineers continued to refine the system, but the fundamental issues remained unresolved. CAT's refusal to acknowledge the problems alienated customers and dealers who were dealing with the consequences daily. Behind the scenes, Caterpillar's refusal to adopt SCR technology like other manufacturers reflected both technical pride and strategic miscalculation. The company's engineers believed that urea injection systems were unnecessarily complex and that ACERT's combustion-based approach was superior. This decision would prove to be a fatal mistake as 2007 emission standards approached. The end came suddenly and shocked the entire trucking industry. In 2010, Caterpillar produced its final on-highway engine, the C15 SDP, marking the end of its long legacy in road-going diesel engines. The decision wasn't driven by competitive failure. It was a strategic choice that prioritized other business segments over trucking. Caterpillar's leadership had concluded that the on-highway engine market was becoming too regulated, too competitive, and too demanding of resources that could be better deployed elsewhere. The company's construction equipment and mining machinery businesses were more profitable and faced less regulatory pressure, making them more attractive investments. The 2007 emission standards required diesel particulate filters and more sophisticated after-treatment systems that Caterpillar was reluctant to develop. Rather than invest the hundreds of millions of dollars needed to create competitive emissions technology, the company chose to focus on markets where its existing expertise provided clearer advantages. The decision was also influenced by Caterpillar's assessment of the competitive landscape. Cummins had established a strong position in the North American market, while European manufacturers like Volvo were gaining ground with advanced technology. CAT's leadership concluded that the investment required to regain dominance in the market wasn't justified by the potential returns. Caterpillar's attempted re-entry through a partnership with Navistar proved to be a costly failure. The CAT CT660 truck, launched in 2011, was supposed to demonstrate that Caterpillar could compete in the complete vehicle market rather than just engines. The truck used a Navistar-supplied chassis and max force-based CAT CT series engine, while transmissions and axles were sourced from leading commercial suppliers, not proprietary to Caterpillar. However, the partnership collapsed as Navistar's EGR-only emissions strategy failed spectacularly. The MaxxForce engines suffered from reliability problems that damaged both companies' reputations, and the CT660 never gained significant market acceptance. Caterpillar discontinued the truck in 2016, ending its brief return to highway transportation. Industry reactions to Caterpillar's exit ranged from shock to disappointment to anger. Dealers who had built their businesses around Cat engines suddenly found themselves without a product line that had been central to their operations. Customers who had been loyal to the brand for decades felt abandoned by a company they had trusted with their livelihoods. The timing of Cat's exit was particularly painful for the industry because it came just as emissions regulations were becoming more stringent and complex. Operators who had relied on Cat's engineering expertise to navigate regulatory challenges suddenly found themselves without that support, forced to switch to competitors they had previously avoided. Independent mechanics who specialized in Cat engines faced the prospect of retraining on different technologies or losing customers to dealers who could service the engines that replaced Cat power plants. The knowledge and expertise that had been built around Cat engines over decades became less valuable overnight. Today, the 3406 engines that built Caterpillar's reputation are still being rebuilt and running strong, serving as symbols of what the company used to represent in the trucking industry. These engines continue to accumulate miles decades after their manufacture. Proving that the engineering philosophy that created them was sound, even if the business strategy wasn't sustainable. The restoration and remanufacturing industry that has developed around 3406 engines demonstrates the enduring appeal of Caterpillar's approach to engine design. Companies like Cat Riemann continue to rebuild these engines to original specifications, and many operators prefer remanufactured 3406s to newer engines because they understand the technology and trust its reliability. The contrast with manufacturers who adapted and survived is stark. Cummins embraced emissions technology and electronic controls, becoming the dominant force in North American trucking that Caterpillar once was. Volvo invested heavily in advanced technology and now offers some of the most sophisticated engines in the industry, with fuel efficiency and emissions performance that ACERT never achieved. These successful manufacturers recognized that the industry was changing and adapted their strategies accordingly. They formed partnerships with suppliers, invested in research and development, and accepted that the future would require different approaches than the past. Their willingness to evolve allowed them to maintain their positions in the market. Caterpillar's exit from on-highway engines represents one of the most significant strategic retreats in American industrial history. The company that had defined reliability and durability in trucking chose to abandon the market rather than adapt to its changing requirements, leaving behind customers who had been loyal for generations. The decision also reflects broader changes in American manufacturing, where companies increasingly focus on their most profitable segments rather than trying to compete across multiple markets. While this approach may make financial sense, it represents a loss of the industrial diversity that once characterized American manufacturing. Cat still builds engines, massive power plants for mining equipment, construction machinery, and marine applications where the company's traditional strengths remain relevant. These engines continue to demonstrate the engineering excellence that made Caterpillar famous, but they're not for the truckers who once considered Cat engines essential to their success. The yellow paint and Cat logo still command respect in heavy industry, but they're no longer part of the American highway landscape. The engines that once powered the nation's freight have been replaced by competitors who were willing to adapt to a changing world, leaving Caterpillar's trucking legacy as a reminder of what happens when pride prevents evolution. Did you run a Cat engine? Share your stories about the engines that built their reputation, and tell us what you think about the company that walked away from the drivers who made them legendary.